Okay, I think we should be live because it tells me end stream. So if I can end it, I guess we are live. If we are live and people are watching us, can you tell us if you can see us and hear us? Oh, yay, I see us too. So hi, everyone, and welcome to the GraalVM for JDK 21 release stream. Let's maybe give people another minute to join, and then we can actually begin. In the meantime, maybe you can tell us in the chat where you are from and just introduce yourself.
Rotinator already said, what is he supposed to be watching? The Java channel or the GraalVM channel? I think you made the right choice.
I know
Good
the
to see you
feeling. We've
here.
been watching the Java channel before our stream as well, so we know the feeling. Yeah, I see some familiar faces, so you can say hi to Gilles and Ola from the GraalVM team.
Hi, Michael. He's also joined and decided for GraalVM.
Yay. One display for work and two for the streams. I think that's good priorities. We approve. Okay, 36 watching now. I think we can actually start. We skipped the introductions part. Maybe we can do it now. So hi, everyone. My name is Elena. I'm a developer advocate for GraalVM. And here with me is my colleague, Fabio. Hi, Fabio.
Hey, Elena. Good to see you.
Good to see you too. And as you can tell, Thomas is not here with us today, which is a bit unfortunate. Thomas is talking about GraalVM at Oracle Cloud World. So it's me and Fabio today, and let's wish good luck to Thomas. But Thomas is with us probably in spirit, so it should be fine. So we are here with you to talk about GraalVM for JDK 21. Today is the actual release date. We are very excited, and I hope that you're excited as well. And I think it's great news because today is also the actual Java 21 release. And by having the GraalVM release on the same day, you can get the best of both worlds. You can use the best and latest Java features together with the latest GraalVM features. So let us know in the comments if you are as excited as we are. And let's see what's actually in this release of GraalVM. So this should be good. And let me go to the, oh, okay, I guess I should have said this. Let me go to the release blog post so we can see what's in this release. So today we are releasing GraalVM for JDK 21. And as you probably know, we've been talking about this for a while now. We are focusing on the latest Java releases. So with each GraalVM release, we will be basing it on the latest Java release at the moment. Today, it's JDK 21. So if you want to get the latest GraalVM features, what we are offering you in this release is JDK 21 based GraalVM build. And as our friend Josh Long always says, be the change you want to see the world, right? So move to the latest Java features. And that's the approach that we are sharing as well. So move to the JDK 21 build with GraalVM. And let's see what's actually in this release. So as always, you can get the downloads from graalvm.org/downloads. That is for both Community Edition and Oracle GraalVM Edition. And first, we will talk about what's new in JDK and native image. And then we will take a look at Truffle and GraalVM language updates because there are many changes in that release as well. I'm just looking at the layout. I think this looks okay. Fabio, maybe if you could move the speaker video under the screen, maybe it will be easier to read what's on in the blog post.
Like so.
I have a delay, but I hope it's fine. Okay, let's see what's in the release. The first thing we want to talk about is AOT at the speed of JIT. And this is a big theme that we had for the past few releases. So we want to make sure that with native image, you can run as fast as you normally run your applications on the JVM. And this is a very ambitious goal because we all know that JVM is great for optimizing for peak performance. And it's amazing. It's so because you have your profiling feedback, you have dynamic code execution. So JVM is really great at optimizing for peak throughput. But we believe that with native image and with ahead of time compilation, you can achieve the same peak performance. And we want to illustrate this in this release. So here we will look at performance metrics for Spring Pet Clinic, which is a very common canonical application for benchmarking Java apps. And if you remember in the previous release, we talked about how we measured various performance metrics for this Spring Pet Clinic application. And we saw that startup, memory usage, packaging size, even latency was already better on native image of Oracle GraalVM if we were comparing it with the C2 JET compiler. But also in this release, we've made several new changes. And now we see that also the peak throughput of native image is ahead of JET. So not only on par, but we see that with native image, you can get even better performance, specifically peak throughput on native image, as you would on the C2 JET. So Fabio, what do you think about this change? Are you excited about it?
Of course, of course. Well, I mean, lots of people had concerns that you can't reach JIT performance, but especially with profile guided optimization, where you can feed profiling information back into the AOT part of native image. Yeah, we can actually beat performance, not just because we have access to almost the same profiling information, but also because of that additional closed world assumption and the additional optimizations that AOT allows us to do on your image. So yeah, that's very excited. I think it's super cool that we finally reached this point, and well, this is a benchmark, right? So you should go and measure this for your own applications. And if you come across examples or scenarios where this is not the case, we want to know, right? So please file issues and get in touch with us on Slack. We like to look into performance bottlenecks and make sure that you're getting the same results as we do.
Yes, agree. And I think Fabio brought up a very interesting point. And this is IoT versus JIT performance is something we can talk about for hours. But I think Fabio mentioned one more specific thing that I want to highlight. It's how native image compiling application ahead of time under closed world assumption indeed has a bit more time and resources. And having this closed world assumption can apply more aggressive optimizations than JIT. So coming from the Java world, we always assume that JET is the best possible mode of executing applications for peak throughput, but there are certain advantages that IoT has as well. And here in this pet clinic example, this is something we see very clearly here. And I'm looking at the comments in the chat, seeing if there are some questions yet. So people are excited about the release. Yay, we are happy to see it. And about SDK Man and seeing the new release there. So I believe this might take a couple more, hours, hopefully. So it probably will not become like right now, but we hope this will become available soon. But the fastest way probably to get the builds will be from our website and GitHub, etc.
Yes, at this point, the process is pretty much automated. So it's just a matter of, I hope, hours until SDK Man is live. It shouldn't take us as long as it did last time because we made so many changes. But this time should be smooth. It's indeed still syncing. Yes, it is indeed still syncing. Hopefully my audio is better too, Simon, now.
For me, it's fine, but please, Simon, let us know if the audio is still unbalanced. Yep. Okay, let's see what else is here. So we still talk about performance because we like performance a lot. So just to recap our all kind of complete benchmark observations from this pet clinic application. Here we are comparing running application on Oracle GraalVM native image versus running on C2 JIT. And C2 JIT is the default top tier compiler that you get in your OpenJDK, etc., in your basic JDK distribution. So here we are comparing native image versus basically an OpenJDK setup. And you can see that, yes, startup is very fast. That's something we know about native image for a while. Memory usage is also significantly lower because you don't need that whole code execution infrastructure at runtime anymore. And what's interesting here, once again, we see that latency is also better on native image. So if you have some strict latency, let's say SLA requirements that you want to meet, this is something that with native image is possible as well. And again, throughput here is better. And I want to talk about one more interesting metric, which is throughput per memory. So how much of throughput, so of actual kind of valuable work you can get out of your application per memory usage and per time. So having some resources at hand, whether locally or in the cloud, how much throughput you can get from your application. And here we are comparing that throughput per memory on native image versus JIT. And we can see how it's almost 50% better on native image. And that's because throughput is comparable, as you've seen, or slightly better on native image. But because it uses significantly less memory, you can get, per given amount of resources, get more throughput. And to illustrate this in another way, here we tried to map throughput per memory, so requests per gigabyte per second versus XMX, and see how much throughput per memory you can get per given XMX size for your application. And what we see here, so the native image is the orange line and the blue one is C2JIT, is you can see that no matter how big or small your application and its heap is, you would get more throughput per memory from native image than from JIT. But another thing that I find particularly interesting is if you look at the first kind of, 20% of this chart. So for application with small or medium heaps, maybe up and around 1 gigabyte, you can get almost twice the throughput per memory from native image as you would from JIT. So this shows here that for apps with small and medium heap sizes, if you care about resources usage, you would get more throughput per memory from native image than from running in the JIT mode. So just to summarize this section, you can see here on the example of Pet Clinic how you can get great peak performance and great other performance metrics on native image when comparing to JIT. So you don't need to give up any of performance aspects at all. And there are a few more performance updates in this release that we cannot wait to talk about. I just want to see if there are any other questions here.
Yes, let me bring up, I think it was Andre's question. What about CPU utilization? We see on our production that the consumption is greater on the native opposite JIT. Okay. Well, usually that shouldn't be the case. So either you're hitting a weird bottleneck, or something else is going on. But yeah, we'd like to know. So usually there should be better CPU utilization because there's no just-in-time compiler running anymore while the application is running. And if you're maximizing for throughput, you probably should be using G1, GC, and PGO, and then you should also see better CPU utilization in total. Right. Okay, looks good. Thanks, Simon, for confirming my audio is better now.
Yeah, but the CPU question is really interesting. I agree that normally should not be the case. So if you could share more details with us, probably on GitHub, about the exact application you're running, GraalVM version, etc., that would be very interesting to know. Oh yeah, and there is a point from Sean from our team that higher CPU should be associated with increased throughput. So maybe if you're getting more throughput at the time and you're realizing CPU better, that could be the case. But in general, if you could share more details with us on GitHub, I think that would be very helpful. Okay, let's move on to other performance updates. So as you know, we are all about performance. So of course, we have more performance news in this release. One more thing is that G1 GC that Fabio just mentioned now also works on Linux AR64. So there could be multiple kind of ways and strategies how to maximize performance of your application. But the typical scenario that we recommend trying out is trying profile guided optimizations, PGO, in the combination with G1 GC. And that is most likely the setup that will give you the best peak performance of your native image applications. So now this is available also on Linux AR64. And one more interesting thing in native image is that now we have an update to our optimization levels policy. And I want to take a step back and quickly mention one particular optimization level, and that is the -OB. We introduced this quite a while ago, but I often see that people still somehow kind of forgot about it or maybe don't know about it. So as you're still developing your application and you want kind of faster development cycle, you want to use this -ob flag that will speed up the build process and give you kind of faster builds. But this is something you only want to use in development. And then as you are moving your application to production, you want to optimize for peak performance instead. And then you want to switch to probably default, which is -02, because -ob will give you faster builds, but at the cost of not giving the exact same peak performance. This is for development purposes. And then for production, you want to use the normal maximizing optimization level. And what's new in this release specifically is that we added a new, even higher optimization level in Oracle GraalVM, and that is -03. So that will optimize for the best peak performance. And this is something that you can kind of trigger and pass as a flag yourself. And also, if you are using PGO, it will be triggered automatically to give you the best peak performance. But also this means that we now expect the default optimization level O2 being a bit faster. So you can expect something like 10, 15% faster compile times. So faster builds and more performance with new third level of optimizations. Okay, what else? Okay, I see excitement about G1 GC. I think that most of the time people are not using PGO. Well, this makes us a bit sad if you're not using PGO, because we are really trying hard to make it easy to use and as efficient as possible. So if there is something about PGO that is stopping you, that you think we could improve, let us know, because we believe that PGO is really essential for optimizing for peak performance, and we want you to use PGO a bit more. Now, how does everything interrupt with generational ZGC? So we added support for ZGC on JIT, I believe, in previous release, right? I'm not sure where we are with generational GC. I don't think that's happening, at least in this release, for sure.
Nope, not happening in this release. So to answer the question, Daniel, the Graal compiler doesn't support generational GC, at least in this release. And because of that, native image can't support it, but also there's no ZGC in native image. Right now there's only G1. Right. What else is there?
The thing preventing us from using PGO is the licensing. Yes, indeed, PGO is available only in Oracle GraalVM. But, as of the last release, we have the GFTC license. So hopefully it will make it a bit easier to adopt Oracle GraalVM, and in particular PGO, as a feature. Okay, let's move on and let's see what else is new in this release, and more specifically for native image. So we have quite a few changes around the build process. One thing is that now you can use the option parallelism to control how many threads are being used by the build process and how many resources it's being using. And also in the build output that is being shown when you are building your application, we now show the memory and thread limits for the build process. And I believe, Fabio, this is the time when we wanted to take the new GraalVM for a spin and show how all of this works in practice.
Yes.
Yay, take it
So
away.
let's see whether I can share my screen.
You should be able to.
Okay, might need your help.
Yep.
Can you see the GraalVM website?
Okay, sorry, I enabled the wrong.
Yes.
Yep.
That's fine.
Yep.
Yeah.
Okay.
So what I want to show real quick is something that we've been talking on Twitter for a while now with Josh. Josh Long was experimenting, or wanted to be an early adopter for the JDK 21 release of GraalVM. So he went out and tried to build and put everything together, build a Spring application with virtual threads enabled, and of course turn that into a native executable. So I wanted to reproduce that, and instead of copying his code, I started from scratch. So I quickly want to show you what I did. Went to the Spring Initializer website. I picked Maven because that's what I wanted to use, and I also needed the milestone 2 for virtual thread support, I guess. I'm even selecting 17 as my Java compliance level, which is fine. You can, like, Java is backward compatible enough. You can compile this application fine with Java 21 or with the GraalVM for JDK 21, I should say. And then I added the usual native image support, GraalVM native support, and Spring Web, because I wanted to build like a tiny web application. Then you can get a preview what that project looks like. I downloaded that project and then I put this into my editor. So this is the application unzipped, and I already extended it just a little bit, and I copied some of Josh's code actually. So he shared he used this, which essentially is just a new virtual thread executor, which then prints a Spring Boot app running on virtual threads before actually running the application. Right, so this is using the new virtual threads API that's available in 21, and then it starts the normal application. And then there's just a hello controller, which sends a greeting from Spring running on virtual threads. And to tell Spring Boot to run and to actually use virtual threads, you only have to flip an application property, which is this one, like Spring threads virtual enabled, and set it to true. And that's all I had to do here. One of the new things that we introduced in this release is a toggle to toggle colorful output that is actually handled automatically by the build tools which are used in here. But the other thing that I wanted to do here in this live stream is use the new parallelism option and reduce the number of threads the analysis is going to use, or the builder is going to use, to 8, so that my computer doesn't freeze when I'm presenting, right? Because otherwise, by default, it would try and use as many cores it can use. So you can already see I was also experimenting with G1 and monitoring options. So these are all disabled. And then I can go ahead and, first of all, just run the application. So let me get this out of the way.
And as you were showing the build file, I just wanted to point out that now you don't need to enable virtual threads as a preview feature in GraalVM, because it's not preview in GraalVM anymore. It's GA, involves JET and native image. So yay, fully supported, and we will see now how it works.
Yes, so I can run it on the JIT, and here my little script is really simple. It prints what version I'm currently using, and I'm using the 21 release from today, and then I run maven spring boot run, and then it does its thing until it starts. Here's the message that's printed before the application starts, and then there's the Spring banner. And here we go. We have an application up and running in a little bit over a second, or 1.5 seconds actually. And when I now go into my browser, I can go and, I think it's 8080. Yep, here are the greetings from this process. I can kill it. And so that's the usual JIT deployment. And I can also build a native executable out of this using native image. So here I'm using native compile, or the terminal. Here we go. So here I'm using the native image from Oracle GraalVM, which was released today. And then I'm running the Maven native build with a native profile, and I'm skipping the test to speed this up a little bit. Spring prepares reachability metadata for us, which is needed to make the native image builder work, and to deal with reflection and things like this. Then it also does this process AOT step where it quickly spins up the application to generate more metadata, I guess, and configuration for native image. And then we move on and finally reach the native compile step. And it's using GraalVM, and then there's a whole bunch of output, which is executing native image, and then it has a massive class path. So we scroll all the way down, and here's our parallelism option. So, and this is the parallelism option 8. It's a needle in the haystack here, but I'll show you where you can find this better. Here's also something new. So you already get warnings that there is an experimental option being used. We'll talk about this in just a bit, but this is essentially coming from Tomcat, which are shipping their own metadata, and they're using an option which we marked as experimental in this release. And then finally, we get to the point where we actually start and build a native executable. So this should look somewhat familiar. Here we're using the 21 release again, and it's actually using a machine learned inferred PGO profile. You can click on these things and go to the documentation. Again, there's some experimental options and where they come from. And then we get to the new build resource section. So here you can see my machine has something like 64 gigabytes of memory, and the builder has decided to use 42% of this at most, which is quite a lot. But we'll see whether it actually needed all of this memory. And then it only uses 8 threads instead of 16 because I set the parallelism flag. So this is where we can quickly check this. Unfortunately, during the analysis, like this logging framework, I believe, was started, so we get some output from there. But then the analysis ran in 35 seconds. So this is the usual output that you would get. And we just reached the end. So this is it was compiling and then creating an image. The image is a little over 80 megabytes. And here we can see the breakdowns of these things. So 16 megabytes coming just from Java base, and the second is Tomcat already. And then there's our native image runtime in terms of code. And then in terms of image heap, there's a lot of strings in these applications, which is not uncommon. There's some resources in here, so 273 resources. And again, some of these things are linked, so you can click on them and learn more about what's actually going on. You can use our build reports, and there's also a new security section now. So this binary includes Java deserialization. So I don't want to go into too much detail, but click on the link and then read up on it. And of course, you can also use SBOM. And there are more recommendations. So you can use G1, which I didn't use here. You can use PGO. There's a new strict image heap option, which we're going to talk about in a bit. And the other recommendations we already discussed, I think, last time. So now the process was done, and it only used 5.6 gigabytes in peak memory in total. Well, that is not as much as it was allowed to use. It was something like 26, I think. Where did it go? Here, 26. So it's only using 6, less than 6 out of the 26 gigabytes. So just because it is allowed to use a lot of memory doesn't mean it actually will use a lot of memory. And this is a good indication. Like if this was my build machine, I could now lower my memory for this machine to something like 8 gigabytes, maybe even 7 gigabytes or 6, and then save costs essentially. And this used something like 8, or this put something like 8.75 on in terms of CPU load, which is pretty close to 8. Yeah, it's sometimes a bit more, sometimes a bit less. And then we ended up with the executable. So now I can run the executable, and we get the same process. It's running with Spring. It's running with virtual threads. It's printing the same banner, and it booted in 40 milliseconds, which is much faster than the second or 1.5 seconds that we saw previously. And just to be sure, yes, this is still a functional application. Any questions, Alina? Was I too quick?
No, I think it was perfect. There are questions, though I think they're not directly connected to the demo, right? But since we're looking at the questions, maybe we can address them anyway. There was one question, or rather, I don't know, a comment about seeing kind of projects going in the same directions. That's being GraalVM native image, Crack, Project Layden, PGO, and Daniel was asking if there could be a bit more unified strategy on that, since it looks like there might be complementary ways to solve a similar issue. And I agree with you that those projects are probably a sign that many people or many teams in the community are trying to solve this one particular challenge, and that is to see if we can reduce startup times and use some kind of snapshotting mechanism to improve startup times of our applications. And I personally think it's great that in our community there are multiple efforts and there is kind of diversity in the options that we can choose if we want to have a solution for warm-up of our application. And in terms of unifying and having a unified strategy, yep, there is some alignment probably happening, and I hope that we can see more of it in the future. But for me personally, that's a sign that what we are doing with GraalVM and specifically with native image, this is something that is needed in the community and being recognized in the community, and that we are going in the right direction.
Yes, and I'd like to add something to Daniel's question. He mentioned Craig, and Craig is not just about it's purely about improving startup. But I'd like to remind you that native image is more can do more than just improving startup and reducing memory resources, memory usage, and resources in general. I think is the real important aspect, because this is actually lowering your costs. It's cool that you can start your applications really fast, but with Craig you will still run on OpenJDK or Hotspot, and that means you will still have a JIT, you will still have a lot of memory consumption, and that is something that you can't provide with Craig. But you can do this with native image. And yeah, Leiden has a very generic approach with these condensers. Maybe native image could become one of these condensers with lots of restrictions. We don't know. It's something that we still need to discuss and want the community to discuss. But yeah, it's still early stages, I would say. So moving on, Fantasy had a great question too. So the question is, if there is a recommended way to build Linux distribution inside a Docker container. For me, it takes 30 minutes for a Hello World, and if I build it like directly on my Mac, it only takes 3 minutes. So to me, this sounds like that your Docker container may be a bit under provisioned, and you may not have enough memory in this Docker container. And then what happens is the garbage collector within the builder starts to do its work, and then it will slow down the build crazy instead of like killing the build eventually. So maybe you get lucky that you can still build the Hello World, but I would certainly look at like how much memory is there. Look at the build resources section, make sure there is enough, and compare that with a build that runs fine on your computer. So if you know in your Mac it's building fine with 8 GB or with 5 GB, make sure that your Docker container has the same amount of memory, right? So let's see what else is there.
Yeah, and that was actually a comment that I also want to bring up about the memory as well, right? About how in the past you could need some extra memory specifically for the native image builds. Yeah, could be the case in the past, but since a while ago, we are reducing the memory requirements of the native image build. We will talk about it in a bit, but some time ago, we introduced some changes, and we see even kind of larger applications building with something like 2 GB of memory available. So yeah, making improvements there, and we will talk about memory in a second.
Yeah, and Andre is actually confirming he can build fine in 8 GB in 2 to 10 minutes. So that's very good. There's a bunch of open source projects that leverage GraalVM native image in GitHub Actions, for example. And the free runners that you get, they have 7 GB of memory. So, and I've seen Petlinik build in there just fine. We can build larger native images for our Truffle languages, for example. We can even build polyglot languages, polyglot images in these containers. So yeah, there's a lot that you can do with 7 GB, but a default of 2 GB, which Sean, for example, mentioned, which sometimes really is the default, is probably not enough to build a Hello World in a reasonable amount of time.
Okay, I think we can move on.
Okay, want to take over?
Yeah, I'm taking over. Okay, let's see what else is new in native image. So we talked about parallelism and we talked about updates to the build output. Now there are also those changes to the memory limits of the native image build that I mentioned. And what's new in this release is that by default, the build process will only use the free memory. So the memory on your machine that is actually free and available at the moment, it will only focus on that one, not to put too much stress on your machine and the other processes running. Now, if there is less than 8 GB of memory available, the build process will use a fraction, 85% of total memory. So if that's your case and your setup, and you see that maybe your machine is being slow as you're building your application in this kind of more constrained environment, consider closing maybe other processes that you might not need at the moment.
And this is exactly for these container use cases as well. Like nowadays, developer machines usually have at least 8 GB of memory, or probably 16, maybe even more. You've seen my machine has 64, because sometimes I need to develop on multiple operating systems at the same time, which is fun, and then build native images. But yeah, coming back to the algorithm, like if there's not enough free memory, then native, to like not cause any swapping on your computer, then native image will fall back into this mode where it takes 85% of total memory, and then it can compete with other processes. So this is a best effort to like or a trade-off between these. I have a developer machine with an IDE open and lots of other things, and lots of yeah, free memory or used memory, we don't know, versus we are building in a container, in a containerized environment where really there's just a native image process which is allowed to consume all of the memory essentially in this container to make best use of your resources.
Thank you, Fabio. And in other changes in native image in this release, so now our native image inspect tool can dump the heap of your executables and shared libraries. And there is one more interesting update related to how we handle missing metadata in native image. So as you know, native image requires metadata for to build your application for things like reflection, serialization, etc. And previously, if such metadata was missing, it could lead to program misbehaving, and sometimes that was hard to debug. Now, in this release, if specifically metadata is missing, we will have special exceptions to handle missing metadata for reflection, resources, serialization, etc. So now, even if such build will fail, you will have a proper exception kind of helping you figure out what to do with the build. And another interesting change in this release is that now we also have a new class initialization strategy. So now it makes it possible for all classes to be used and initialized at build time, no matter how they are configured. So even if they are configured to be initialized at runtime, it means that they will appear kind of like uninitialized again at runtime. And this is in this release, this is behind a flag. So you can pass this strict image heap flag to give it a try in this release. And we plan to publish a bit more detailed blog post to talk about this new class initialization strategy and why do we have it in the first place, pros and cons of the existing approach and the new approach. But also we have a very detailed pull request on GitHub from when this was merged. And if you are curious, you can give it a try now. And we will actually be interested in hearing your feedback if you try it and how it works for you.
Yeah, there's just one thing that I'd like to note here is that if you're using the option and you run into errors, we unfortunately made a little problem sneaked into the release that actually causes the error message itself to fail, which covers then masks the underlying cause. So we already have a patch for it, but it didn't make it into the release. So we'll, with the blog post, hopefully have an updated GraalVM release in October with the patch update. And that will give you, that will help you look at the real cause of the error that you're getting if you're using this new flag. Without the flag, everything should work just as before. We expect the microservice frameworks to adopt the option first. We have already adopted it in the native build tool. So if you're using our Maven and Gradle plugins, that should not be in the way of using this flag. Once the update is out, we'll have another blog post, explain and motivate this change again, and explain why this is the right thing to do and why we're doing this in the first place. It's a good and useful change, but be aware. There's a little problem in there.
Okay.
Any news about cross compilation?
Yeah, that's the question we get every time.
Yes. Well, no. Well, initializing a JDK for a different platform is really hard. Of course, it could be done, but it's probably much easier to like emulate the whole operating system and run the build in there. Yeah, different architectures or different CPUs is also a good question. Well, we haven't made any progress so far. Oh, no, I don't think there's an update.
So typically what you want to do is to use kind of CI/CD system to build for different platforms. Another possible solution can be if you have kind of access to those machines that you are targeting. In the previous release, we introduced native image bundles. So you can bundle your application and then easily reproduce a build out of that bundle. So maybe that's also a solution that could work for you. Okay, what else? What about cases when it is expected that a method, field, constructor, or even class does not exist, will this throw the new missing metadata exception? So if I get this right, I don't think that's the case for this missing metadata exception. But maybe Fabio, if you know more, or if there are native image people in the chat, maybe they can.
Yeah, I think you're correct. This is well, if there is no class that should exist, then this will throw, or it will actually return null. I think class for name should return null. I'm not sure. Either it throws a normal exception, but anyway, the whole motivation for this missing metadata exceptions is that you have a chance to run in a mode where you can trigger a dedicated exception and make sure that you don't fall into the normal fallback code that would otherwise be triggered if the reflection code is not supposed to be working. So in some frameworks there's some reflection stuff going on, and if something is not there, it will do something else, and you don't know whether sometimes you don't know whether it's doing something else. So you can turn on these exceptions, and then you get a dedicated missing metadata exception which tells you what metadata is actually missing, like class X is requested, but it was not registered for reflection. And then you need to register it for reflection so it is reachable and included in the executable and registered for reflection. And then you can actually use that at runtime just fine. So yeah, definitely take a look at the roadmap item as well on GitHub, which has lots of details.
Okay, let's see what else there. I see that we have quite a few questions. So what about the native image static build on macOS, problems with the Darwin?
Yeah, I don't know where we are. I think in terms of static images, you can only build them on Linux, really.
Okay, there is a comment about microarchitectures and using the arc flag.
Yes, that also makes a lot of sense. I mean, if you're building images, or if you're building with native image and then deploying on a different machine with a different CPU, then you shouldn't be using -march native. You should only use -march native if you're really building on the same machine that you're deploying on, especially when you're switching between Intel and AMD or different CPUs, right? But this is not too uncommon. If -march also comes or is supported by Clang and GCC, and it's the same thing there. So in some ways, if you're using -march, you become something like a C programmer, right? But you're writing code in Java. So yeah, you need to think about these things and make sure that you're essentially deploying on the same machine that you're building on if you're using that flag.
And I see a question about difficulties building a Spring Boot multi-module app with GraalVM, but I would suggest that's probably a Spring Boot issue. At least it sounds that way, but without seeing the details, kind of hard to tell.
Yep. And then there is Oleg.
Yeah, Oleg has a very good question.
Can you compile Kotlin C to native image? Well, Oleg, I don't know. If
I
if
feel
you
like
were
Oleg could give it a try and tell us how it worked out for him.
Exactly. Well, Oleg should give this a try. If it worked before, then it should also work with the new class initialization strategy. That's for sure.
Or maybe
So,
it's bad enough. So maybe Oleg can try it and tell us what he found out.
right.
It seems the multi-module GraalVM doc is not so available.
Yeah.
Okay.
I don't know what this means. Maybe you can clarify a bit more in the chat.
Yeah. Okay. But let's
Should we
move
move
on.
on?
Yeah,
Yes.
because we have a lot of stuff and we still need to talk about Truffle updates. So let's see if we can move on. So we talked about new class initialization strategy in native image. Now we are making some changes around packaging. So for example, GU is no longer needed in this release. So for native image, you just get native image in your GraalVM JDK. And then for GraalVM languages, there is a new way to use GraalVM languages that we will talk about in a second. But long story short, you don't need to use GU, which is the GraalVM updater, the tool that you use to install additional components in GraalVM. This is not needed anymore. And we will talk about how you would use additional components in a second. And just to summarize this developer experience section, we also now have support for the GFR event strat CPU load that was contributed by Bellsoft. So thanks for the contribution. Now, in other news for native image, we also have a new option in native image, and we want to give you a bit more control and awareness of the options that you are using in native image, because there are many options that you can use for your native image build, and most of them are stable, but there are also some experimental ones. So we want to add this new option to unlock and then lock the use of experimental build options. And with this way, you will have more control and kind of more awareness of which experimental features you are using. So this will become required in the upcoming release to specifically unlock the use of experimental features, but you can already give it a try in this release. And also, as we are stabilizing the public API, we are looking forward to your feedback of which experimental features you are using at the moment so that we can know and keep this in mind as we are working on the API. Okay, and just to summarize the native image update, there is just one more thing that we want to mention, and that is an additional security update. So now there is one more security feature around control flow integrity in native image that is using hardware to verify the integrity of the return address of a function call. So this is something you can try in Oracle GraalVM with this enable CFI option. Okay, and in other news, as we said, we have GraalVM for JDK 21 build. So this is also available for the compiler. You can use GraalVM as your normal compiler and your normal JDK. And also on the compiler side of things, we added support for the Java Vector API operations optimizations. So related news is that we also refactored the GraalVM SDK, and the main part there is that it's now being split into 4 fine-grained modules. Probably the things you'll be more interested in is that there is now a separate module for the native image, so for more advanced native image use cases, and the one for Polyglot. And we want to briefly talk about ecosystem updates and community, and then we want to switch to Truffle and GraalVM languages updates. So if there are more questions that you have around native image and JDK updates, now would be the time to ask them so we can move to other components. Okay, so in other news, we just had, I think, 2 days ago, maybe a new release of native build tools that Fabio mentioned. So Maven and Gradle plugins for native image have now the latest version of 0927. And GraalVM reachability metadata, I think there was a question or a comment from Simon hoping that we got new contributions to this repo because they are very helpful and this repo is very helpful. So indeed that happened. And if you go here, okay, this is taking a while to load. I don't know if that's GitHub or my connection. But if you go to the actual repo, you will see that we had a new release and there have been contributions of several projects, and there are metadata now in this repo that helps you figure out metadata needed for native image builds. So indeed, there have been some contributions, and now you can use more libraries and tools and frameworks by using metadata from this repo. That's one update. And in other news, in the GraalVM ecosystem and community, so there have been a new release of the Micronaut framework, that's 4.0. And we saw a very cool story of 10-minute mail using GraalVM and Spring Boot, and how they moved the startup time of their applications from 30 seconds to about 3 milliseconds. And also memory usage was also significantly reduced. And we saw similar updates that were shared by the Ballerina team, where they said the same thing, basically how their application now starts much faster and it's using way less memory with GraalVM. And we often get this question of how do frameworks compare to each other, or which one should I use, or what do I need to know about the frameworks. So Matt Rabel did this nice comparison of performance of various frameworks and how they work with GraalVM and how they perform in terms of startup, memory usage, other aspects. So those were the JDK and native image updates that we had at the moment. I'm looking at the chat and I don't think we have any more questions, at least for now. Fabio, do you have something else to say about JDK native image, or should we switch to the Truffle updates?
No, if I look at the time, it's a good time to start talking about Truffle updates. You
That
want
is
to go
great.
over to the other release blog posts?
Yep, I'm switching
Okay.
now. Yep. So just like last time, we have many updates. So we have two separate blog posts covering them both, one for JDK native image and another one for Truffle and GraalVM languages. So in the Truffle world, we have this big change and kind of project that we call Truffle Unchained. And this means that now Truffle, so GraalVM's Polyglot runtime, and also GraalVM languages, so other languages that you can use on GraalVM, such as JavaScript, Python, Ruby, etc., are now decoupled from the GraalVM JDK. This means that you can now download standalone languages from GitHub, and we will see that in a second. But also, this means that there is a new way to embed applications to embed such languages in your Java applications. So let's talk about two different use cases here, how you would use GraalVM and Truffle to run your let's say, Python JavaScript application, and then how would embed such languages in a Java application. So first thing is about standalone language runtimes. So if you just want to execute, let's say, plain JavaScript, Python, Ruby, etc. code, you get those standalone language runtimes from our team. And now we have for each of those languages standalone runtimes in a form of native and JVM runtimes. So native one is a natively compiled native image-based language runtime that will start very fast. And then the JVM-based one is, well, based on the JVM, which will give you additional interop in with Java applications. And also for each of those language runtimes, we have additions for Community Edition and GFC-based Oracle GraalVM. But
So if
yep.
if you're wondering what a standalone language distribution actually is, it's supposed to be or intended to be like a drop-in replacement for the corresponding language interpreter. So, for example, for C Python, you can drop in this GraalPython standalone, and it's essentially like a directory with a bin directory, and that only includes Python and Python-like things. And no Java C or Java in the native configuration. If you want the full Java interoperability, essentially what you would get if you installed Python into an older GraalVM JDK with the GraalVM updater, then you would pick the JVM standalone download essentially. So this is for like language users, like a JavaScript developer, Python, Ruby developers. These are the standalones. And then there are the embedding use cases, which is you're building a Java application and you want to use one of our Truffle interpreters or one of these languages to extend your Java application. And the thing that has changed here is that now you don't need to geo install Python or JavaScript anymore. What you do instead is you define a well-defined dependency, or actually multiple dependencies in your POM or Gradle configuration. And that allows you to then directly use our Polyglot API, which is the Java API for interacting with Truffle languages, really.
Yeah. So this is indeed a big change, specifically around polyglot embedding. And to cover this and talk a bit more in detail about why we are doing this, how things will work from now on, what are the implications for you as a user, we have one more blog post that I want to mention. So we have also a Truffle Unchained blog post dedicated to this whole project from our Truffle language component lead, Christian Hummer, where he talks in detail about what are the changes that we are making, why, and how will you use languages from now on. But indeed, the main changes are around the polyglot embedding and how you would use GraalVM and Truffle to embed other languages in your Java application. What's interesting, this is indeed kind of decoupling Truffle and GraalVM languages from GraalVM as a JDK. So now, if you wanted to, you could also use those languages in any other compatible JDK. And we have a page on the website talking in detail about how you can use Truffle and GraalVM languages on any other JDK. So this is a big news here in this release, and we encourage you to check out that other Truffle Unchained blog post a bit more about for details about this change when we are making this and what you should know as a user. And we have a very cool also a Polyglot embedding demo on GitHub where we have an entire project that you can build and run for yourself and see how you would now configure such embedding use cases.
Yes, and in case you're wondering whether you can still build like a native image out of this, yes, you can. And that's also part of this demo that Christian put together in his POM or Gradle configuration. He essentially has like all the languages in there that you can use and uncomment. And he has a little example in there too, like a simple hello world. And of course, you can run all of this on a normal OpenJDK or GraalVM JDK, but you can also compile the application with our Maven or Gradle plugins into a native executable. And then you end up with a Java application that has a Ruby or a Python interpreter burned into the or persisted into the executable, and you can ship this instead of like a full-fledged JDK deployment. Okay, you good, Alina?
Yeah, sorry, I had minor interruption, but we are good. We can move on. So let us know what you think about this change. And I'm looking at the comments and what else is happening there. So yeah, Roland says he loves GraalVM. We do as well. And there is one more comment from Andre about that it would be nice to fail the build if reachability metadata repository is enabled but not configured. I'm not sure you would want to fail the build in that case.
I wonder what this means. There's not much that you need to configure because
I mean, you can specify a version, but that should not fail the build, right? So
yeah, well, maybe you can clarify and file a ticket or feature request for us, Andre. How about that?
yeah, sounds good. Okay, let's see what else is here. So we talked about removing GU and what are the implications for you as a user, how you will install languages. So basically you would just use them as Maven dependencies, but also we described in detail what you need to do for each component if you want to use them from now on, now without GU. We have it somewhere, was it up here? Yep, so we have a list of all components and what you need to use to have now in GraalVM for JDK 21. Okay, and yes, more detailed in the related blog post. And we talked about GraalVM SDK changes. So obviously this has implications for Truffle users as well. You would now need to use the Polyglot part of the SDK. Okay, and
there's another question coming in. Wait a second, I can combine Java and, for example, JavaScript, Python in one application, let the two languages talk between, I guess, each other and compile it into a native image. Yes, you can. Well, you can in this release, it's a minor detail, but we have this new pass once flag enabled now for Truffle languages as well, which was needed to build Spring applications too. So that means you can build a Spring application and then embed or a Micronaut application or some other application and embed one of these languages in the application and turn that into a native executable. So yeah, maybe someone has the time to do this.
Okay, let's see what else is new here. So basically for each language, we will have this update, and now we have those standalone distributions that are available on GitHub. And then if you want to use this language from a Java application, we provide you a way how you would enable it in your build file. For JavaScript and other updates is that it no longer ships with the JS script engine. This is something you would need to enable as a jar on your module path. And also we made the ECMAScript 2023 features now enabled by default. Okay, and let's talk about GraalPy. So GraalPy is now also available under the GFTC license. Yay! And you can get both Community Edition and GFTC-based Oracle GraalVM builds from GitHub. Actually, maybe we can give it a try and see if the builds are there. Okay, I think they should be, but we can check later. Or you can also use pyenv to install the latest version of GraalPy. Now, what else is new in this release for GraalPy is that we now have a distribution for Windows that you can easily just install and use on Windows. And there are some known limitations and restrictions in this release, but pure Python code and pure Python packages should just work. And I know that many users were waiting specifically for Python on Windows. So now this is actually available as a distribution that you can just get and use. And as always, we are continuing the work on the compatibility of GraalPy and making more packages available for you in the GraalPy implementation. So for example, in this release, we added support for SQLite 3, and this also enabled some other packages to be available as well. And one more interesting thing that I want to mention is that we also contributed support for GraalPy to the GitHub's setup Python action. And this is still work in progress, but I believe we are very close to getting this merged. So hopefully soon you will be also able to use GraalPy straight in GitHub Actions. Okay, what else is new? Let me see at the questions.
Someone is asking whether we have any plans to support Swing in native image. Swing is built on top of AWT, and that is on our roadmap. It is supported on Linux and Mac OS if you're using the tracing agent to collect reachability metadata. It's a bit complicated to make or support AWT on native image. First of all, we want to add. Oh, did I say macOS? I wanted to say Windows and Linux. Yeah, macOS is still pending. So once that's in, we want to take a look at how we can automate the configuration process for AWT, because AWT uses a lot of native code and requires lots of configuration, which will be really hard to maintain. So long story short, it is planned. It's probably not the highest priority at this point, but we're making progress in every release.
Thank you, Fabio. I think that was it for questions at the moment. Yes, let's move on. So Truffle Ruby, similar updates. Again, we have both native and JVM standalone language runtimes available on GitHub. And what's interesting about the native standalone of Truffle Ruby is that on Linux, it now uses G1GC. So if you're using Truffle Ruby specifically on Linux, you can now expect performance improvements. And you can get the build from GitHub. And actually, we went through this one pretty fast. So if you have more questions, I think we have some more time for them. So you can ask either about native image or about Truffle updates. In the meantime, we just want to once again remind you where you can get the GraalVM builds. So you can go to graalvm.org, and this is the place where you can get the GraalVM for JDK 21. So you can see it's already on the home page. You can learn straight here what is new, and this is the place where you can download GraalVM. We are at the top of the hour, but I think we have some more time for questions and comments if you still have some.
Yes, while we're waiting, Alina, what are you doing in 2 weeks?
Oh, funny you should ask, Fabio. So you and I are at Devox Belgium talking about GraalVM and all the cool things you can do with GraalVM and native image. And we have a deep dive. So this means that we will be talking about GraalVM and native image for 3 hours.
Yes, and we'll be at the GraalVM /Oracle booth if you want to come by and say hello. and tell us how you use GraalVM.
Yes, so we will be there, I think, the whole week. So even if you don't make it to our session, you will have plenty of time to talk with us and tell us what you like about GraalVM and what you think we can improve. Okay, then it seems to me that we are out of questions. I see a lot of excitement to go and try GraalVM. So maybe we can give people the time to actually do it. I believe the build should be already available last time I checked. So maybe you can already give them a try and let us know how you like it and what is your favorite feature in this release.
Yes, should be up in SDK Min very soon. You can already use it with GitHub Actions, download it off our website. Homebrew is updated, I believe. So yeah, go and grab the latest GraalVM release while it's hot.
And we've been also told that the container images are coming up. So basically, any way that you can download and consume GraalVM should be available very soon. So give it a try and let us know how you like it. And thank you for spending this hour with us. Now go and try GraalVM. Okay.